Hey everyone, and welcome back to our Python data analytics series. In this episode, we're going to go over the concept of data exploration. We'll learn how to view data to get insights from it, ways you can select specific data from your dataset, and also ways in which you can manipulate data in such a way that it makes it more understandable. In our very last video, we obtained a dataset from Kaggle that gives us the AI global index for all the countries of the world. For the sake of staying consistent, we're going to be using the same dataset for our episode today. If you need help getting this dataset, check out the previous video or look in the description for the dataset link. I went ahead and copied the code chunk where we loaded in our dataset from the last video, and already ran it and selected the CSV file. Make sure you do this each time you're relaunching Colab or reconnecting to it. I've also just made a quick dataset.head block here, just so we can get kind of a glimpse of what our dataset looks like and what we're working with, just like we did in the last episode. So let's go ahead and run this, just so we can print off the first 5 lines of our dataset. We have all the code set up to load our dataset in and view it using the head function. And now we should look at the next step in the data process, which is using functions to help us view and select data that helps us better understand our dataset. Before we do any sort of manipulation of the dataset or explore any other functions, let's use an easy pandas function that gives us a good overview of the dataset. So pandas actually has a describe function that shows things like the mean, standard deviation, and percentiles of each variable in the dataset. So I'm going to scroll down here to where we have our describe function comment here, and I'm just going to call dataset.describe like this. And then if we run this, it'll print out a very nice and concise summary of your dataset and each of its variables. So, for example, we can see that the mean value of operating environment is right here, 66.92. And then we could say, for instance, okay, let's find the 50th percentile of infrastructure, and it'll be 65.23 like this. So note that the describe function only prints out the columns that have numerical values, since we can't do this kind of numerical analysis on, for instance, the region column where we just have words like low, medium, or high, because it wouldn't make sense to find a mean for things like those. So this describe function is really useful to give us an idea of what our data actually is and what each field looks like in terms of its statistics. The thing I usually look at with this table the most is the mean, min, and the max typically, because the mean is good just because it gives you an idea of what the actual average value is per field, and the min and max is good because it gives you an idea of what range the numbers actually fall in, and can also potentially signal some outliers too. I would definitely recommend using this describe function on a dataset if you're just getting started with it and need a starting point. As data analysts, it's often necessary to take a look at just one column of data. Similar to how we access any object properties in regular Python with square brackets, we can do the same with the data frame in pandas. So let's go down to our singular column selection comment down here, and I'm just going to make a new line. I'm going to type dataset, and I'll do square brackets, and then as a string, I will pass in the column talent. So if we actually run this, you can see that now it just prints out every value of the talent column in order. So if we actually just scroll up and look at the talent column in here, you can see that all the numbers match. So we have like 100, 16.51, 39.65. Go down here and it's the exact same thing, because when you select it like this, it is literally just printing out the talent column. We can do this with any variable we want. We just need to make sure we use the square brackets to access it and type in the correct name of the variable or the column. If I wanted to list out all the values, let's say for research, I could just replace talent with research like this. And then I could run it, and it would do literally the exact same thing, just with the research values. One thing to make sure of is that the word matches exactly what the title matches. So like research here, we need to make sure you have a capital R, just because it is capitalized up in here. If the cases are off, it won't recognize it, and it'll throw an error for you. So one thing to note, however, is that it may be difficult to tell which value actually corresponds to which country, since the countries are what identify each individual row. So to help us look at this a little bit better, let's select just the country and talent columns instead of just the talent column. So we'll look at some multiple column selection here. So to do this, I'm going to go into this multiple column selection block here, and we need double square brackets instead of single square brackets if we're going to select multiple columns instead of just one. So what do I mean by that? Let's look. So if I want to select multiple, I'll do dataset. I'll do the same brackets as before, except if I want to select multiple, I need to do double like this. And then I can pass it in kind of like a list, and I'll just say country, comma, talent. And this is because we need to use square brackets to actually access the columns, so that's these yellow ones here. But then we actually also need to use square brackets to denote a list, which are these purple ones right here. So if I go ahead and just run this, you'll see it prints out both the country and talent columns. This gives us a super easy way to see all the talent values for each country. One neat thing you can do with this kind of thing is save subsets like this inside of a new data frame so you can easily reference it in the future. So instead of printing this whole thing out, we can just make a new variable. Let's just say, we'll just call it like talent data frame for right now. And then we can set it equal to all of this. And then anytime we want to see this data frame again, we can just access this talent data frame by just writing its name and then running it and printing it out, and it just do the same thing. But I could also access it in like future blocks if I ever needed this data frame for whatever reason after calling this line. One thing that's very important is that we want to make sure that when we're creating new or experimental data frames like this one, that we're not overriding the original data set. If I were to say, for instance, like right here, data set, like that, instead of doing like the talent data frame, then this is actually going to overwrite the data set and turn it into just this data frame with countries and talent. And then if we want to do anything with any of these other fields, we won't be allowed to, so we'll be forced to reload the data set from the very top. So just a rule of thumb, never do this, never pollute the original data. So I'm going to go ahead and just Control Z that. If you want to make new data frames to help you with insights or whatever else, make new variables for them and then modify those variables however you want. So next, let's go ahead and move on to two of the most useful functions you're going to find in pandas, which are lock and iloc. Lock is just short for location, and iloc is just short for integer location. So lock uses actual labels to identify rows and columns, whereas iloc uses integers to identify rows and columns. Basically, these are the primary functions you're going to be using to select a specific chunk of data, and how you use these functions varies only slightly. So the first one I actually want to go over is lock, which uses row and column labels to grab data. So if we actually scroll back up to the top here, we can see that in our data set, every row is labeled by a number, for instance, like 0, 1, 2, and then every column is labeled by some word, like country, talent, infrastructure, and so forth. So I'll go ahead and scroll back down here, and I'll explain exactly how lock works. So lock works basically by just passing in the title of the row and the title of the column in order to get a specific value. So let's say, for instance, I wanted Canada's research number. So to do that, I would just type dataset.lock, and I'd use square brackets, and then Canada is number 3, that's the row they're in, and then I want their research value, so I'm just going to pass in research. Within lock, the row always comes first as the first argument, and then the column argument always comes second, and they're always separated by a comma. So basically just looking for Canada, which is row 3, and we're looking for the column titled research. Note that normally when you call a method or a function on a data frame, you need to use parentheses. However, with some functions that involve indexing and selection, like lock and iloc, you actually need to use square brackets instead, just like we would with our regular column selection. So now if we run this code and print it out, you'll see that it prints out 30.67 because we asked for the piece of data at the row labeled 3 with the column labeled research. And if we actually scroll up here, we can look at Canada and we're looking for research in this row, and you see it actually is 30.67. So basically, anytime you pass in a specific row with a specific column, then you're going to get a single value that's basically corresponding to the conditions, which is going to be a single cell. However, let's say we just want to actually select one row instead of one whole cell. So if we want to do that, we don't actually have to pass in a columns argument. So let's say we want in just Canada in its entirety. I could actually just pass in the number 3 here, and it'll assume we're wanting all of the columns. So if I run this, you'll see that it gives me a table like printout. It has all the numbers and everything for Canada. So we have like 31.28 for talent, 77.05 for infrastructure, and so forth. Technically, I could also add like a comma and a colon like this and get the exact same thing if I run it. So if I did that, we get the exact same thing. This just explicitly shows the column argument because if we put a colon by itself, it means select everything. But you could omit that if you wanted, just like this, and it'll give you the exact same result. Let's look at another example. Let's say we want to get the United States number or their score for development. So the United States is very first in the list, meaning they're at label 0. So I could put 0 here. And then I want to get their development number. So I would put a comma, and then I would put development like this. And then if we print it off, you get 100. We can scroll up here and verify that number is right. Like United States of America, development score of 100. So that makes sense. If I wanted to print out just the United States line in its entirety and not a specific column, I could just delete this development string like this to basically print out the entire United States row. So now, what if we want to actually select multiple rows and columns? So one way we could do it involves using commas to separate out different criteria, and the other way involves using the slicing operator just like we would in regular Python. If we pass in multiple criteria for the rows or columns, we're not going to get a singular value, but rather a list of values depending on what we pass in. Okay, so for example, let's say you want to find the research values for the UK, Canada, and Israel. So I'll make a new lock statement here. I'll just type dataset.lock with square brackets. And instead of just passing in one row number, a 3, let's pass in a list of row numbers. So I'm actually going to do another square bracket here to denote a list. And I'm going to pass in 2, 3, and 4. And that is because if we scroll up, we can see that 2 is United Kingdom, 3 is Canada, and 4 is Israel. So those are the corresponding row numbers. So if I were to go ahead and just run this, you'll see that it just prints off the rows for the UK, Canada, and Israel. If we do it this way, note that the order does actually matter, because if we type, for instance, let's say 3 and then 2 and 4, and then print it out, it'll print it out actually in that order. So it'll do Canada, UK, Israel instead of UK, Canada, Israel. So the order of these arguments does matter in terms of how it's going to be printed out. Since we're selecting all the columns, this is another example of not having to specify a column argument. Because if we wanted a column, we would type something like this, where you do column and then, some column argument here. So let's say we actually do want to look at multiple columns. We still want to look at the UK, Canada, and Israel. However, now we want to print out values for country, research, development, and government strategy. We can do a similar thing on the columns argument that we did for the rows here by using commas to separate out different criteria. So to do that, let's make another list here, which we'll denote by square brackets. And then we're going to pass in a few strings for our column names. We're going to say country as one. We'll say research for this one, developments, and then we'll type in government strategy. And so then, if we run this and print this whole thing out, it's going to print off the rows that are equal to, actually I'll change this to 2, 3, and 4 real quick. Run it. It'll print off the rows that are equal to 2, 3, and 4, and then it's going to print out the columns that are equal to country, research, development, and government strategy. So because we're selecting multiple criteria for both rows and columns, it makes a neat little table when we run this function. The values in both the rows and columns are sequential in this case, meaning they are all side by side in the dataset. However, we could switch these up if we wanted to. So instead of 2, 3, 4, let's just type in, let's say 10, 20, and 30. And then instead of country, research, development, and government strategy, we could just write something else here. I won't change it for right now, just to show you the sequential things for the rows. But I could just run this and you see now it gives us another table that has Australia, Spain, and Italy. However, if the values are sequential, there is a much easier way to do this rather than listing everything out with commas. We can use the slicing operator from Python to select the data in a more effective way. So I'm going to just go in here and just do Control Z. Let's just get these back to 2, 3, and 4. And then actually I'll just go ahead and run this real quick. So for the rows, rather than typing out every single number row we want, like 2, 3, and 4, we can instead just write something like this, where we do 2, 4. So why does this work? Well, this is the Python slicing operator, and it selects every number in the given range. So the colon represents every number between these two numbers, which basically means if we're writing 2 to 4, we're selecting every row between row 2 and row 4, including rows 2 and 4 themselves. And we'll actually need to remove these square brackets here if we want this to work, otherwise it'll throw us an error. So we can run it like this, and you'll see it prints out the same thing as the 2, 3, 4, except we don't have to explicitly write out the number 3, because we're just using the slicing operator. So this slicing operator comes really in handy when you want to do a lot of rows but don't want to list them all out. For example, if I wanted to do rows 2 through 10, I could just do 2, 10 like this, and it would print them all out. The plus side of this is that if I wanted sequential entries, like side-to-side entries, I don't have to explicitly type out, 2, 3, 4, 5, and so on. And this rule actually applies to columns in the exact same way. So let's actually remove the square brackets of the columns here. And if we scroll up to the top here, we can see that country, talent, infrastructure, operating environment, and research are all sequential entries, meaning they're all side by side. If I wanted to select all these columns, I could do a slice operator on these as well. So let's go ahead and go down here. I said I wanted to select everything from country to research. So let's actually do something like this. We'll type country slice research like this. So this slice takes everything from country to research, which will include columns like talent and infrastructure. So if we actually run this now, you'll see we have the exact same result as we would if we listed out each one individually. In the same way as rows, it makes it easier if we have many things to enter. So if, for example, we wanted to get everything from research to total score, we can just do something like this. We'll say research, and then, then we can just type in total score like this. And then if we run it, it would just print out every single one of those columns without me having to explicitly actually list out each one with separation by commas. So just so we can go back to what we had before, I'm going to quickly Control Z this so we have country to research. And basically, long story short, with this line, what we're doing, for our first argument, which is our row argument, I'm selecting every row between 2 and 10. And then for our second argument, which is the column argument, I'm selecting every column between country and research. The result is a table matching those exact criteria. So real quick, if you're familiar with Python, you might be slightly confused with the slicing operator, because normally the slicing operator includes the number before the colon, but excludes the number after the colon. However, because these numbers aren't actually indices, and instead they are numeric labels created by the data frame, both the first and last number in the slice will be included. So like these numbers you see here, these 2, 3, and 4, these aren't technically index numbers, they're actually just label numbers. So when you do something like 210, it will include both the 2 and the 10, whereas in normal like Python slicing, if you were to do this, it would include everything from 2 to 9, but it would exclude 10. So one thing that makes slicing a lot easier is excluding numbers before or after the slice operator. So if I wanted to select, let's just say the first 10 rows, normally you could do something like this where you say, 0 to 10. However, I don't actually need to specify the 0 at the start of the slice. So if I wanted to actually just exclude it, I could just delete it like this, and then it would print off, actually I'll run this here real quick. So you can see it looks like that, and then if I were to delete the 0 like this and print it off, it would give us the exact same thing, because if you basically omit the thing before the colon, it just auto-fills in the 0 for this. And I can actually do the exact opposite if I want to grab only the rows 10 and after. So instead of writing colon 10, I can actually write 10 colon like this, and it will know that I want all the rows from index 10 to the very end. So basically fills the last thing in here, like auto-fills it. So now if I run this, you'll see it prints out, see it starts at 10 and then prints off every single row until the very end of the data set. And easily enough, the same rule actually applies to columns as well. If I wanted to grab, let's say, everything up until the research column, or every column up into the research column, I could actually just delete this country here, like this, and we have colon research, and it would do the same thing since country is in the first column, so it looks something like this. Or if I wanted to do the reverse, I could do research colon, and then that would select every column from research until the very end, like this. Lastly, if I want to select every single row or column within Iloc, I can just type a colon with literally nothing else. So when I had something like this, where I had 10 colon, it autofills the end number with the last possible number. And then when I did something like this, where I had colon 10, it autofills the beginning number, which is 0. So meaning if I actually just combine those two things together and I just do just a colon, it'll autofill both the 0 and the very end. So basically it'll grab everything in the possible range of numbers. So if I write it and run like this, it'll literally just print off every single row. This slicing operator is incredibly helpful in a lot of different scenarios. However, one weakness it has is that if you want to select data that isn't sequential. For example, if I wanted to select the columns talent, operating environment, and development, there's not a super simple way to do that with the slicing operator. In the case of data like that isn't sequential, it's better to just use commas to separate them out like we did earlier. Otherwise, if it is sequential, use a slicing operator. Now that you have a solid understanding of how data selection works based on specifying rows and columns within Iloc, let's look at one last thing before we move on to Iloc. So what if we want to select given rows based on values within the column? So basically selecting data based on a condition. For example, what if we want to select every single row that has an income group of high? This is what we would call filtering, and it's fairly easy to do and also uses Iloc. So we'll go ahead in this code block here, and we'll just write dataset.lock with square brackets to go ahead and get it started off. Now, we want to select all the rows where a particular column has a particular value. So how do we do this? Well, we can actually use the bracket selection operator we showed earlier to select the column. So I can do something like this. I can say dataset, and then let's say we want to look at the income group column. So I'll just type income group here, again, using the regular selection that we just showed earlier in this episode. So how do we actually narrow this down now? Well, if we want a condition to filter on, we can actually just type something like this equal sign, and then whatever value we're actually looking for. In this case, we want to look for, let's say, rows where the income group value is equal to high. So I can say equals high. So all this line is basically saying is give me the locations, or in other words, the rows where the column income group is equal to high. So if we go ahead and run this line of code, it only prints out the table with countries that have an income group of high. You can actually see that if we look over here. There are no countries in this table that have an income group that is not in the high level. As another example, let's just say we want to find every row where the region is in Europe. We could just change this line here, and we could say region inside the brackets to specify the region column, and then we say where it's equal to Europe. And then, if we run this, it'll only print off countries that are in the region Europe. With numerical values, you can do something really valuable as well. You can actually use like the less than or greater than symbols to select rows based on those criteria. So let's say I wanted to only look at countries that have a development score of over 50. I could replace this column we're looking at here. I'll just replace it with development. Oops. Say development. And then I'm going to type greater than 50 like this. And then if we run it like this, you'll see that it only prints out 3 countries, all of which have a development score of over 50. Note that I could also use greater than or equal to, so I could do like greater than equal to, and I would write it like this, and I could run it, although in this case it yields the exact same results. And in the same way, just like greater than or greater than equals to, I could also use like less than or less than equal to. For instance, I could say countries with development score of less than 50, and if I ran it, it would print out a whole lot more countries, all of which have a development score of under 50. So next, what if we want to actually select data based on multiple criteria instead of just one? There's a way to do this with checking multiple values in a single column, as well as checking multiple values in multiple columns. So the first way we can do this is actually very straightforward, and it's just using the isIn function from pandas. So let's say in this data set, we actually want to select, let's say we're going to look at the region column, and then we basically want to select countries from Europe and the Americas. So we'll go ahead and have this here. And then what we can do is use this isIn function. So we just type it like this. We would do isIn. And then in here, we would pass in the values that we're looking for. So we said we're looking for countries that are either Europe or Americas. And actually, we'll make this a list here so it doesn't throw us an error. So we use square brackets like this. And then if we actually run this code, it now prints out all the countries in Europe and in the Americas. So basically all we're doing here is the regular bracket selection. We're selecting the region column and then using this isIn function, using this isIn function to basically check whether the value is equal to either of these values in this list, which are Europe and Americas, and it prints it out accordingly. The nice thing with this format is that we can kind of just mess around with this as we please and add things kind of as needed. So let's say we want to check the region still, but we want to add another region in this filtering here. We'll just add Middle East. I can just add a comma here, and I can just type Middle East, and then if I were to run this here, it would do the same thing with Europe and the Americas, but it would also include countries that are in the Middle East. The other way we could check for multiple conditions within multiple columns would be to use the AND operator like we would in normal Python. So I'm actually going to take this line here. I'm going to copy and paste it, and I'm going to go ahead and go down here and just paste this in so we can have a separate block to show you this. So let's add something in combination with what we already have in this line, which is just selecting the countries from Europe, Americas, and Middle East. We now also want to check countries that fall in these three countries that also have an operating environment score above 70. It's actually pretty straightforward to do this. So inside of our lock statement, but outside of our initial condition, we're going to add just a singular ampersand symbol, or I call it the and symbol sometimes, and then we'll select the other column. So we'll do dataset, and then we'll select operating environment like this, and we're going to say where it is greater than 70. And real quick, before we run this, one thing that I realized when testing out this function is that if you have two or more conditions like this, you'll want to wrap each condition in parentheses, or else sometimes Pandas gets a little confused with the ordering and doesn't run correctly. So I'll put this in parentheses here with this condition, and then I'll also put this in parentheses here. So basically, any condition on any side of the and symbol needs to be in parentheses. So now, if we go ahead and run this line here, and we take a look at this data set, you'll see that the only rows that are actually printed out are the ones that have an operating environment score of over 70 that are also located in Europe, the Americas, or the Middle East. I could, of course, switch around any of these variables to mean something different. For example, changing this, changing this greater than sign to a less than sign, which now, if we run it, would print off every country that is still in these three regions with an operating environment score below 70. Let's do one more example so you get the hang of this. So I'll go ahead and scroll down here, make a new line here, and let's say you want to now print off every country where the infrastructure score is above 50 and the region is Asia Pacific. In this case, we can just say, we'll say dataset.lock, and then we said infrastructure above 50 and region Asia Pacific. So in our two conditions, let's just type dataset, and we'll select the infrastructure column, and then we'll say where that is greater than 50, and then we'll do our and symbol just like we did last time, and also parentheses just to make sure it doesn't get confused, and then we'll say dataset, we'll select the region column, and then we'll say where the region column is equal to Asia Pacific. So now we can go ahead and run this code, and you'll see it prints off only countries in the Asia Pacific region that have an infrastructure score of above 50. This method of filtering can be super helpful for trying to look at data that falls within certain ranges or meets certain criteria. If we're using and symbols, we could actually use as many as we wanted to. For example, right now we just have two conditions in this line separated by an and symbol, but if we wanted, we could have like 15 or 100 conditions all separated by and symbols. I'm not sure why you'd ever need that many, but the option is there to use as many conditions as you possibly would want. Now that you should know how to use lock to locate specific chunks of data based on different criteria, let's next look at iloc. iloc works pretty much in the exact same way as lock, except instead of using the labels of rows and columns, you instead use the index number. So let's go down here and we'll actually make a new code block down here. And let's say I want to retrieve the first 4 rows of the data set and display the development and government strategy column for all those rows. I could write something like this. I could say dataset.iloc 0 to 4 and then 5 to 7. So why did I choose these numbers? So remember in Python that everything you have within list or any like multiple data type things are going to be indexed by 0. So for example, if we're looking at a table of our full data set, which I'll make a quick code block here. I'm just going to print off, I'm just going to print off dataset.head, pass in 5 just to be explicit, and then I'll run this. And notice that for all these rows, it starts at 0, 1, 2, 3. I said before, these are actually not indices, these are technically just labels. However, we can actually look at it in an indexed way. So in any list-like things, whether it's the rows or the columns, the first is always going to be index 0. So this is index 0 row. This would be index 1, index 2, index 3, and so forth. And the exact same thing applies to the columns. So this column is index 0, this column is index 1, this column here, infrastructure, is index 2, and so forth. So hopefully you get the picture there. So basically for the rows here, when I write 0 slice 4, I'm including everything from index 0 to index 4 here. However, now that we're dealing with actual indices, this 4 is not going to be included in the slice, meaning that we're only grabbing 0, 1, 2, and 3, because in normal slicing, the last index is actually excluded. And then for the columns here, you see we passed in 5, 7, and I said we wanted to select the development and government strategy column, so let's actually count over the indices here. So country is index 0, talent index 1, infrastructure is 2, we have 3, 4, and then 5 is development here. So development is in column indexed 5, and then government strategy index 6, and then commercial is index 7. But again, because this is the last number in the slice, being 7, it isn't going to be included. So we're actually just going to be grabbing 5 and 6, which is just development and government strategy. So now if I go ahead and run this code, you'll see that it prints out rows 0, 1, 2, and 3, and then the columns development and government strategy. So just so you get the idea of how this works, let's do another example, just so you can understand. So let's say I want to use iloc to select the first 10 rows and display the last 4 columns. So let's make a new iloc. We'll say dataset.iloc, do our square brackets, and we know the first 10 rows will be indices 0 through 10. So we can just type :10 like this. And then to find what we need for the indices of the columns, let's just go ahead and count over. So we want the last 4 columns, including, let's say, region, cluster, income group, and political regime. If we count over the indices, we have 0, 1 with talent, 2, 3, 4, 5, 6, 7, 8, 9. So it appears that region is at index 9. So we said we wanted everything from region to the end since we're doing the last 4 columns. So we can actually just type 9 and then colon here to select everything up until the end. So now if I go ahead and print it out, you'll see we have every row from 0 to 9, which is the first 10 rows, as well as the region, cluster, income group, and political regime columns. Pretty much all the exact same rules with iloc are the same with loc, so I won't go over every selection we did with loc. However, again, iloc just uses the index of the row, label, and column rather than the name of the label itself. Typically when I'm doing this kind of work, I like to use loc instead of loc because it is more intuitive to me, and you don't need to count all these label indices because that's kind of an inconvenience in my opinion. Hopefully now you have a solid understanding of data selection in pandas using loc and iloc, as well as a solid understanding of how general data exploration works. The lessons learned in this video are very essential for being able to manipulate data in the way you want it, so make sure to go back in the video and double check if there are any spots you aren't 100% sure on, especially the section where we went over loc because that'll come up a lot in our future episodes. In the next video, we'll cover the idea of data cleaning and just general mutation. I'll see you in the next one.